We all know how dinosaurs met their demise. The asteroid impact, global fires, marking the end of a geological era. Yet, few understand how these magnificent creatures first began their reign on Earth. This narrative unfolds over 200 million years before that extinction event, when dinosaurs were new arrivals, struggling to establish a foothold. One of the most profound mysteries in evolutionary biology is simple. What made dinosaurs so successful? What unique adaptations allowed them to dominate the planet for over 150 million years? When we envision these ancient behemoths, we think of their immense size, formidable claws, or impenetrable armor. However, their true secret weapon might have been something far more subtle and invisible. That hidden advantage, that crucial evolutionary edge, was their remarkably efficient lungs. As a paleontologist, my research delves into a compelling question. Could the specialized way dinosaurs breathe have been key to their extraordinary survival and dominance? Let's transport ourselves back to the Triassic period, a pivotal era in Earth's ancient history. The world then was harsh, characterized by endless forests of ancient pines and towering ferns. Atmospheric oxygen levels were significantly lower, around 15%, compared to today's 21%. For any animal to thrive, it required a highly efficient mechanism to extract sufficient air from that thin, oxygen-depleted atmosphere. So, what made the dinosaur lung so fundamentally different and superior? While we cannot study fossilized lungs, we use sophisticated methods to reconstruct their probable structure and function. This is achieved through extant phylogenetic bracketing. This approach involves studying the living relatives of dinosaurs, modern birds, crocodiles, and various lizards. By comparing their skeletal structures and respiratory systems, we infer what features dinosaurs likely possessed, and the evidence points toward a respiratory model similar to modern birds. Now, let's explore how this avian-style respiration differs from our own mammalian breathing. Mammals, including humans and my dog Mila of Troy, breathe using soft, flexible lungs. These lungs expand and contract much like balloons, drawing air in and pushing down. This flexibility limits how thin the lung tissue can be. Too thin, it would tear. Birds, on the other hand, ingeniously flip this respiratory design. Their lungs are rigid and fixed firmly in place, like a sturdy sponge against their ribs. Air flows through these rigid lungs in a single, unidirectional path, propelled by separate, balloon-like air sacs. It's an engineering marvel, ensuring constant airflow, preventing lung collapse, and minimizing wasted air. Birds also possess specialized air pockets within their bones, known as vertebral pneumaticity, which locks the system and lightens their skeletons. And when we examine dinosaur fossils, we uncover the same compelling clues. We observe distinctive forked ribs and hollow vertebrae, strong indicators of this advanced respiratory system. This means their lungs were securely anchored, rigid, and incredibly efficient, a breathing machine built for low-oxygen worlds. This rigid lung structure allowed for an ultra-thin barrier between inhaled air and circulating blood, creating a faster path for oxygen absorption. Under challenging Triassic conditions, this physiological adaptation was a superpower, granting them an unparalleled advantage. While early mammals struggled for every breath, dinosaurs were quietly thriving and expanding their dominion. So perhaps the spectacular rise of dinosaurs wasn't solely about their formidable teeth, immense size, or powerful muscles. Maybe it began with something more subtle, yet profoundly impactful, a significantly more efficient way to breathe. That tiny evolutionary tweak, that internal biological innovation, may have been their ultimate launchpad to global dominance. And for me, as a scientist, it's a powerful reminder. Sometimes the biggest changes start deep inside, with the very breath of a creature that simply refused to suffocate.